Welcome to Snark Chocolate, a show about cryptography and cryptography-based products, where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be co-hosting this episode together with Queenie. Today, we are happy and thrilled to be joined by Guy Ziskind, Chief Dreamer and Founder at Fhenix, and Guy Itzhaky, CEO and Founder at Fhenix, who are at the bleeding edge of on-chain confidentiality. We hope to learn more on this topic and get some ideas into what these guys are cooking for us. Starting with introduction. Guy, could you please introduce yourselves and how you came to work on Fhenix?
I guess I'll let you, the other guy, start first.
Yeah, you may want to be more specific, Omer. Hey, great to be here. Thanks for having us. I'm Guy Ziskind. Omer, as you know, we've known for a while. I've been in the space for about a decade now. My roots are in MPC, applied MPC. Like basically in the last decade, I've been trying to solve this problem of on-chain confidentiality. There are many different technologies. When I started also in academia. I got my PhD at MIT, focusing exactly on that. Then I founded Secret Network, which basically brought TEs into the blockchain area. But like in the last, I'd say, few years, I've kind of been watching FHE on the side quite a while and seeing like how fast ZK has moved from like theory to production. It just felt right that the time for FHE is now, and FHE is actually not just a pipe dream anymore, but it's actually something that we can use today. So about 2 years ago, I pretty much dropped everything and just decided to focus 100% on bringing FHE to blockchains.
Yeah, my background is a bit different. Spent a big portion of my career at Intel, leading several initiatives around confidential compute, specifically working on Intel SGX for various aspects, both from just driving SGX into OEM platforms, as well as defining use cases that trusted execution environment can bring value on. Blockchain was one of the immediate suspects. So around 2017, started utilizing Intel SGX and building blockchain-based confidential solutions with it. And then in 2020, I decided to take a leave of absence from the exciting space of confidential compute. Went to work for a couple of years on the Olympics as a technology advisor. And then in 2022, just wanted to go back to that space, and I led Intel's Fully Homomorphic Encryption business development team. And through that, I've just was fascinated with the progression that FHE has made. From a technology which was always considered as very complex and very slow, and I guess we'll touch base upon this later on. It started to feel that FHE is reaching into maturity, and that felt it's the right time to drive FHE into the ecosystem from a more business side of things. Joined forces with Guy Ziskind, and we started Fhenix, and it's been an exciting journey since then.
Awesome, great to hear. So let's jump straight into what is Fhenix. So on-chain confidentiality, we already mentioned that. Maybe you can break it down for us. What's the vision here? And taking it, one step further, I know that in terms of on-chain, you have multiple options. It can be an L1 and L2, a co-process. So maybe you can explain the difference in your view when it comes to fully homomorphic encryption and these different ways to bring it on-chain.
Yeah, sure. I'll start. I think maybe before we describe what Fhenix is, probably worth giving the audience a little bit of background about what FHE is, since we're going to use this term quite a lot during the next few minutes. So FHE, Fully Homomorphic Encryption, is an encryption technology that's, I think, been invented by Craig Gentry about a decade ago. It enables you to run computation on data while the data is encrypted. from the early days, you've seen several flavors of homomorphic encryption. You had homomorphic encryption, you had partial homomorphic encryption, and now fully homomorphic encryption, which enables you to basically do these computation on the entire set of mathematical operations. FHE, when it started, was very computation heavy and also very complex. You had to be a cryptographer if you wanted to actually use FHE. But progression in the last couple of years, both in terms of the actual FHE schemes, as well as tying FHE to just faster hardware, made FHE significantly faster and ready for usage today. So when we started Fhenix, we started it with the goal of bringing on-chain confidentiality across the Ethereum ecosystem. The first Fhenix product that we started building was our layer 2, the Fhenix Nitrogen layer 2. And that is, as it is, it's a layer 2 that just enables developers they write smart contracts to decide what type of data they want to keep encrypted on-chain. But our long-term vision was always to drive FHE across the Ethereum ecosystem, and that is why in parallel of building the Fhenix L2, we also started building the coprocessor, which you can look at it as some sort of a stateless rollup that enables you to actually tap the coprocessor to any EVM chain and provide FHE capabilities to these different chains.
Yeah, I'll just jump in and add on the coprocessor angle. Like really, the way to view the L2 and the coprocessor, they are very, like from R&D perspective, they are very similar. But from a developer experience, right? That's like the intended user. They are quite different in the sense that there are thousands of L2s and L1s. Like these are popping every day. I don't actually think that the distinction between L1 and L2, by the way, matters that much. I think it's mostly a trend, having been around the block a bit. But at the end of the day, like what we are giving is something that is a fundamental feature for any developer in the space. Like in Web 2, we assume that data can be like we can be selective about which data is confidential. When I hail an Uber taxi or like an Uber driver, I expect my location data and my driver expect his location data and the fact that we matched not to be public for everyone to see. Like that's a fundamental expectation in Web 2. In Web 3, we obviously don't have that unless we have something like FHE. But then the whole distinction of like, do we really build our L2? Well, if we build our L2, that means that developers, if they want that kind of capability of being selective about what data they reveal or not, that also means that they have to be building on our L2. And there are thousands of L2 and L1s out there, and even beyond the Ethereum ecosystem. And it was always the case. So like the L2 was more like, in our vision in mind, the L2 was more like a sandbox where we start with. But the vision was always doing something like a coprocessor, because the idea is like if you're a developer, we are not asking you to choose our L2 as opposed to others. Like you should build wherever you're comfortable with. Doesn't even have to be the Ethereum ecosystem. We will bring FHE to you. That's basically the meaning of the coprocessor. Build wherever and just like use FHE and encrypt data in your contracts where you really need it.
Can you walk us through the design of Fhenix as a FHE rollup? How to understand the different designs? Is it a standard rollup with some FHE feature modules, or it's actually fundamentally different compared to other layer 2s?
So first of all, we had a short paper that we published about it. So like people who want to see more details, they can look up like FHE rollups or something like that, or go to our website, phenix.io. You have that there. But generally speaking, it's fairly similar to other rollups with, I'd say, maybe 2 or 3 distinctive changes. So, in a regular rollup, basically you have there's a sequencer who basically takes like transactions, they sequence them, then that sequencer or some other validator does the execution. And then they, either with a ZK proof or some optimistic proof or a cryptocurrency proof, whatever you want, they basically post that state change back to some layer one. I mean, that's your usual rollup. In our case, so first of all, the sequencer doesn't change much, but the validators who do the execution and basically propose blocks, they basically have to also run FHE computation. So basically, we give them like I'd say a modified node, if you will, that whenever they see in the Solidity code like some FHE function, right? Like it's kind of like a precompiled, and they know it's like an FHE precompile, and now they have to run some Rust code that actually does the FHE stuff, right? And obviously on the end user side, when the user starts, so they also have to encrypt their data before they send the transaction to the chain. So like the data in the transaction that the user basically sends is encrypted client side. I mean, this is abstracted away from the user, right? But like that's what happens. So that change number one. You have to, whoever does the evaluation of the contracts actually has to understand like FHE semantics and run those that relevant code. But then the other major part and the other major difference is that you want to keep data encrypted at all times, but sometimes you do want to actually decrypt the data. So let's give a very specific example. Let's say you have a DAO governance voting contract. So you want to keep all individual votes. So when a user basically casts a vote on chain, you want that the individual vote, to be encrypted. You then want to homomorphically, so basically over the encrypted data, tallies everyone's vote. But at the end of the day, you want to reveal to everyone publicly who was the winning, I don't know if it's a prediction market, did option A win or option B or whatever. So now you have to do decryption. And when you do decryption, someone needs to have the key, and you don't want just like one person to hold the key because then they can decrypt everyone's data. So you need, what we do and what pretty much everyone who does FHE does is basically you have a network of validators who hold shares of the key, that's called the threshold network. And so whenever there's a request coming saying, hey, this piece of data needs to be decrypted, then the threshold network gets a request, they decrypt it, and then they post the decrypted result on chain. And that whole concept of like a decryption network obviously doesn't exist in regular rollups.
Yeah, and I think a simplified version to think about it is that regardless whether it's a rollup or whether it's a coprocessor, you have three sets of functions that happens. The first one is the encryption part, where the data is being encrypted. Then you have the operation over that encrypted data, and then you have the decryption. And clearly, like encryption is very fast. That doesn't take any like very minimal time. Operation is the fully homomorphic encryption that operates over the encrypted data, and the decryption, which you want to maintain it in a secure fashion, is where you use the threshold network, where you take the key and you split it into multiple keys, and you run an operation that enables you to compute and to decrypt upon request.
That's very helpful. As what you mentioned about the validators running FHE computation, how does it affect MEV on Phenix?
I mean, technically, FHE, you can completely, or I don't know if completely, right? There's this side channel information and all that, but like you can greatly minimize MEV if you want, because like if transactions get encrypted client side, right, and then you homomorphically evaluate them, then you can greatly I mean, there's way less information for MEV bots or like MEV extractors to basically get from. And actually, even if you don't really care about FHE, but you do care about something like, let's say, post-quantum, cryptography, then probably at some point, I mean, people are looking at like threshold like encrypted mempools, right? Like even Flashbots, they use TE for that. Other products use MPC. But at the end of the day, you encrypt your transactions and blocks to avoid MEV. But most of those schemes are not post quantum secure. Again, I don't know how real of a problem that is, right? Like it's people are talking about it. I'm somewhat split on whether that's a real issue or not. But if it is a real issue, then even if you don't care about FHE, just using like LW encryption, which is basically the thing that underpins all FHE schemes, that type of encryption is supposed to be post-quantum secure. So it's a very, very useful and important tool for MEV, we think, both in Phenix, but even outside of Phenix, to be very honest.
So far you make it sound simple, although I have to admit that from my understanding, it looks like whatever it is that you are touching or trying to build it's not that, it's already so complicated to build like in a decentralized ecosystem and all of this, like in the blockchain space, now you add more complexities and I would like to hear more about the challenges that you guys are facing or faced so far. Can be, introducing security assumptions, uh, the threshold decryption. I mean, there's like a whole bunch of operational challenges that are new here that do not appear in, if you just want to build a core processor or sorry, some kind of an L2 today. So can you share with us some of the challenges that you guys have been trying to crack?
Yeah, there are many of these, and there are different layers. And I think eventually, more companies are looking at these and more projects, and this is going to be a group effort. I don't think any one project can realistically solve everything. One very big challenge is that on the one hand, we're trying to make it very, very seamless. So quite honestly, like writing an FHE, like a smart contract in Solidity that uses FHE is very easy. It's as easy as writing like regular Solidity. So that's a good thing and a bad thing. Like obviously that's the thing we hope for, but on the other hand, there is some paradigm shift here. So if you want to keep data confidential, I mean, let's take a very, very simple example because that might be the way to go. Think about like an ERC-20 contract where you wanna hide your balance and the amount that you're gonna send. Like I'm sending a transaction to Queenie here, and I want to hide the amount that I'm sending her and my balance. So if you look at the code of a regular ERC-20 contract, then you have like an if statement where you check like if your balance is like, if you have enough, if I have enough funds to actually send to Queenie, that's obviously something that you need to do. Now, theoretically, what we see a lot of people do is like they take the same code, which they kind of can, and they work with it. But if you do that the same way, then basically what we see a lot of programmers do, they check if they have enough balance, they decrypt it on chain, and they see like if it was one, like if they have enough balance, that they continue with the execution and they actually send the funds. But if you do that way, you leaked information to everyone, right? You didn't give exactly how much balance you had, but you basically put like some gap, right? Like your balance is greater than 10 or whatever, or like something. And developers, they don't understand that, nor should they. And that's a big challenge. Like, on the one hand, we want to make it as simple as possible. On the other hand, there's a different thinking that needs to come into play here. And I would really want to say that this is solved, but it's not solved. Like, we understand it's well enough to say what's the way you need to write those contracts. But that's not a good answer for developers and for the community. So how do you actually balance like ease of use and let's say developer experience with good programming practices when leaking data is an issue.
Yeah, I just want to add that I feel there are challenges that are perceived challenges and challenges that are real challenges. Some of the perceived challenges is this notion of complexity and performance, and also sometimes even comparing FHE to ZK for people who don't necessarily understand the of cryptography and thinking that they're the same. But these are perceived challenges. They're not real challenges, and we are able to solve them. As we mentioned, like writing a contract is very, very easy. So there is really no challenge in complexity. And also performance is getting faster and faster and will get faster and faster. So this for me is no longer a barrier. Where the real challenges become is when you start working on encrypted data. And there are challenges that we need to maintain the security of the key, which comes into the threshold network, the ability to potentially have a mechanism to recover in case there is a problem there. So these are some of the technical challenges that we are facing. But it is also important to mention that regardless of these challenges, the problem that we are coming to solve, we believe is such an important problem and is fundamental to the maturity of the blockchain ecosystem, that it's worth time to invest in solving these challenges and for user to adopt these type of solutions because this is really where we feel the market will be in a couple of years.
So I want to refer to the first sentence you mentioned, Guy Ziskind, about this being a team effort. And I wonder how does it reflect on the type of partnerships that you have, and maybe also on the competitive landscape, since there are significant challenges that, as you said, cannot be solved by one company.
I'd say, well, first of all, there's a lot of design partners we gather along the way. And one area, look, I don't think they're going to be production ready on chain tomorrow, but like there's a lot of institutionals that's actually now a barrier. Like they want to come into the space. They realize that like running their own blockchains, like between, let's say, three banks is not interesting. But they can't, like, even legally or from a compliance perspective, they can't just like do things like put real world assets on chain and then by that fact basically reveal all of their customer information as they do this, right? Like so that's becoming a major issue, and we are learning a lot from it. Like we did a pilot with JP Morgan on tokenizing real world assets, and confidentiality was like a big issue. That was like the primary issue why they want to use FHE. And actually, even confidentiality was not enough. They even wanted like stronger properties like anonymity, which usually people kind of, it's kind of ironic. Usually people associate that with like money laundering, and here you have like one of the biggest banks in the world saying like, we will not go on a public chain unless we also solve anonymity for our users. Like it's pretty amazing. So that's part of it. And I am very encouraged because like within a few months, like we actually saw like people working, like developers working like in JP Morgan, for example, are able to actually put like real pilot that's usable with this technology. So clearly, and obviously that tells us a lot about how we should build our product better to make it more usable. And if very classical Web 2 developers can make that transition, at least conceptually, then I'm pretty sure that people who are experienced in Web 3 would be able to do that very easily if they want to or they need to. So that's, let's say, on the design partners angle. The other angle is the, let's say, competitive landscape. So there are many projects working on FHE now and on MPC as well. And we are all to an extent running into similar problems. And we are competitors, obviously, but we're also collaborators. Like we talk very, very often. One thing that we do quite a bit is like we work very closely with the Zama team, and there are things that we build ourselves, but there are places where we basically use their product, at least for now, exclusively. For example, their TFHE library for homomorphic operations. And there's but regardless, like we have like, weekly calls, or not weekly, bi-weekly, like monthly calls, and we're trying to create standards. So like we're talking on building like an encrypted ERC20 standard that the industry will adopt. And we're talking with institutionals, and we're talking to the people at the Ethereum Foundation and other places about that. So like we're trying to operate in many cases as a group, because at the end of the day, right now it's a blue ocean and there's still a lot of education to do. And quite frankly, there's no room to compete yet until we basically have brought the market to recognize that they want FHE, that they need FHE, and that there are common standards that make everyone's life easier. If that makes sense. I don't know, Itzhaky, if you want to add on top of that.
Yeah, I mean, on the competitive landscape, I think you touched about the FHE competitive landscape. It's probably worth mentioning that you can actually look at it from a broader standpoint and just look at FHE versus TE versus ZK, which is another domain. There are solutions, there are protocols that are trying to build similar solutions using TEs, and a few that are trying to do it using zero knowledge. Our take is that for the majority of the use cases, FHE is a better solution. It's significantly more flexible for privacy matters and confidentiality matters than ZK-based solutions. And TE-wise, TEs has the advantages of today being faster than FHE. I think that's known. But what we've noticed, and that was actually highlighted by JP Morgan Chase when they did the POC, we asked them, what's your preference, FHE or TE? And they were very clear that their notion is that they want to utilize Fully Homomorphic Encryption because they believe it's the longer term viable solution. So in that regard, I would say these are probably very, very practical when you're talking about encrypting assets, which the security properties of them is not, the importance of that is not extremely high, versus FHE, where you really want to go into the full depth of security properties, and that's when you use FHE. But regardless, I 100% agree with Guy that this is currently a blue ocean, and there will be a time for competition. At this point, it's really just a lot about education and just building the market. And we're actually starting to see fruits here. If you think about FHE a year ago and where FHE is now, you start seeing the Ethereum Foundation mention programmable cryptography. We're talking about ZK MPC, mostly MPC and FHE. So FHE is no longer this lost son. It's actually part of the conversation. And the amount of interest that we're seeing around FHE is just growing as time progresses.
I've seen some people suggest that TE is for today while FHE is for the future. So we can say FHE is for today as well.
I think it's probably going to be both for the long run. Both will be utilized, but definitely FHE is the bet that we are taking, and we feel that this will be the longer term viable option. Quantum compute maybe at some point will also play a role here, but even without it, it just has stronger security guarantees in our opinion.
So what are you working on right now, and how does your roadmap looks like going forward? We mentioned already the move from an L2 to a coprocessor. I assume the threshold decryption stuff, which seems to be quite new as well. What else are you guys building? What areas are you focusing on? Like, is it the user experience, or is it already solved? Like, what's the roadmap looks like?
So I think probably it's worth maybe taking a few minutes to walk through the threshold decryption, since that's a topic that we've invested quite a bit on. As I mentioned, right, when you start thinking about working with FHE, you need to deal with encryption, operation, and decryption. The threshold decryption is a key component, and Guy will get into details around that in a minute. But putting that aside, there is work happening on building the coprocessor itself, and we're going to see it coming into the market very soon. And then it is a matter of constantly improving the developer experience and just making it significantly easier. I'll give just one example that we're dealing with, and that is from a user's perspective, the ability to view their encrypted balance in a very seamless fashion. Is a challenge that many of the projects out there today faces. Just think about it. If you have data which is encrypted on chain and now you're opening your MetaMask, how do you actually see the balance if it's encrypted on chain? So figuring out a solution that would just make this entire experience seamless from a user's perspective is a problem that we have solved. And there are many more of these type of examples where product just needs to meet the user expectation. But probably worth maybe giving a few minutes on the threshold decryption.
Actually, but also before the threshold decryption, like we've been looking a lot around like specific use cases, and the reason we do that is because we have projects building on us that need it. People building like confidential lending, private OTC. If you think about it, the OTC market is really a very, very critical use case where people actually do want confidentiality. Usually, it's like big players, insiders, VCs, whales, people who are actually usually doxed on chain, and they already like now it's kind of like a mess. Like they do this like through Telegram groups and like really that's like it's really broken. So that's like actually a prime example of a use case where it's needed. And there's a company called Silhouette, which is building on us, which is basically trying to target that. And we are working very closely with those teams, and we also have like an internal app team that develops these like POCs and projects. And the reason is that our experience shows that, and especially in crypto, it's easy that when you work on infrastructure, if you don't actually eat your own dog food and actually try to kind of face the difficulties that we're talking about here yourself, then it's easy to sweep them under the rug and just say, oh, developers will figure it out and all that. So no, so like we literally have like an app team sitting next to our infra team working on these, and when they bang the head against the I don't know, they bang their heads because they're unsuccessful in doing in like doing what they want to do, then they just go to the next door and tell the info team, look, this is not good, like we need A, B, and C. And this has been very, very, very a very useful way to kind of like build our product. And then there's the threshold network. And the threshold network is this often overlooked problem that people, especially in FHE, they kind of gloss away. So as Omer, I'm sure, knows very well, basically it's an MPC protocol. Sometimes you need to decrypt. You don't want one person to have the key. So now you have this MPC problem where you want a network of participants to decrypt data at some point. And just so that you get a sense of how big of a problem it is, think about a DeFi protocol. Think about like a DeFi, like something like Uniswap, where all the assets are confidential. When I go on Uniswap or like when I open my MetaMask, I now need to see all of my balances, all of them, right? Let's say I have like 50 assets there. And let's say all of those 50 assets are encrypted, they're confidential. So now I need to go on chain and ask to decrypt, or more correctly, re-encrypt all of those 50 assets balances to me. Those are 50 decryption requests that happen by a single user. So decryption actually happens even much more frequently than even transactions. Like it's a read operation, needs to be very fast and needs to be very scalable. And we ran into that problem because we saw that like our system completely breaks with all the existing solutions because it literally can't handle the throughput. So just to give people a sense, like the state of the art that exists currently, even on like a very massive server with, like 128 or 192 cores, CPU cores, but in GPU maybe it's like 5x better, but like even there, that's gonna do like maybe 5 to 10 decryptions a second. So even one user is gonna completely break that system essentially. Um, so that was a huge issue. We spent like I'd say almost a year maybe, or maybe like 9 months, like solving it end to end. I don't want to get into the technical details. Maybe we can do it later, or maybe by the time this is out, like the protocol will be out. But we really kind of like reimagined like the problem of threshold FHE decryption. There's a lot of work around it. There's like I think like 15 to 20 papers building like protocols for that. And we completely built a different protocol that operates in a very different way. And basically on benchmarks right now, we can do on a single server like that, we can do like tens of thousands, maybe even 100,000 decryptions a second. So from 5 to 10 decryption a second, which can't even handle a single user in the system in a very reasonable application like confidential DeFi or just like looking at your balances. Now we can pretty much handle, I'd say, as many users as we need, which is pretty cool.
Oh, this is super interesting. Looking forward. I guess it will be some kind of a paper and code.
Yes, so there's already like a POC code, again, not out. This is already getting worked into our mainnet product. So in 2 months, let's say we release the first version of the core processor, this will be already for production, or maybe 4 months, something like that. And yes, there's a paper that's getting finalized these days. I expect it to be out in like the next few weeks.
Very, very nice. Staying on the point of roadmap, I want to actually take a step backward. So, you guys have been building on top of Arbitrum, one of the most robust infrastructure that we have in blockchain space. I wonder if you can share about your experience from choosing to work as part of Arbitrum ecosystem, the dev experience, and takeaways from working in that environment.
Yeah, the key reason why we decided to utilize the Arbitrum stack was their ability to support fraud proofs. That is a capability that we believed is essential. And when we made the decision, they were the only ones that offered fraud proofs. And just think about the ability to actually run fraud proofs when you have encrypted data becomes even more challenging. And when we did the analysis, we figured out that there is actually a way to utilize the Arbitrum fraud proof mechanism to run over encrypted data. It's actually all defined in the white paper that we have on our website and people can read. So we decided to take the Arbitrum stack and build a Phenix L2. And we felt it was actually fairly simple. I think they've done a phenomenal job in making their stack quite scalable as well as very easy to consume.
I'm interested in the use cases. So you've highlighted actually several use cases on your website: confidential voting, anonymous auctions, trustless gaming, decentralized identity, and private social networks. Actually, which one of these are you most excited about? I'm actually quite interested in trustless gaming.
I don't want to burst your bubble. I think trusted gaming is very cool. Like trusted gaming is very cool. Like I am very excited about it. Um, I feel, and our assessment right now is that the community is somewhat steered away from on-chain gaming or gaming in Web3 in general. And until I do think there will be a time where that's revisited. That might happen very, very soon, and it might not be. But because like it doesn't seem like the industry is ready for that yet in general, then this is something that we are putting more in the back burner. I am quite frankly, I'm most excited about I think two of these. I feel like the OTC part is something that excites me quite a bit because I know for a fact that's a pain point, having been in the space and working with so many people for so long. And the other one is bringing institutionals. So I think institutionals, it seems pretty clear to everyone that they're going to come on chain with this idea of tokenizing their funds and real world assets. And now with the new regulatory regime in the US, which is basically pro crypto, then that's going to happen much faster. But they just cannot do it without confidentiality. So those just seem like two low-hanging fruit and real use cases that are the market needs today, which is why I'm mostly excited about those. Guy, maybe you have a different take.
No, I think you've hit it spot on. Confidential stablecoin is definitely a use case that we think makes a lot of sense. But I think sometimes when we talk about the use cases, we talk about the use cases that we think are more in the immediate time frame. I actually want to try and take a bit of a zoom out and take more of a visionary approach. We all seen what happened to NVIDIA a couple of days ago with the introduction of DeepSeek. And that's always a question that comes into mind, like when will we have FHE and AI, and when will that intersection happen? So putting aside the timeline of FHE and AI, because it is very complex to run a machine learning algorithm inside of FHE, but definitely private queries is a domain that excites a lot. And we can understand why. When we had models that were maintained by US companies, then maybe it was less of a problem, even though for me it's the same problem. And now that we start to have like DeepSeek, then suddenly everybody says, yeah, you get better performance, but you lose your privacy, as if you haven't lost it when you worked with other LLM out there. So clearly figuring out a way to run LLM models and having the ability to write private queries is something which will come. There is a significant need for that, both from individual users, but also from institutionals, federal entities that will probably want to utilize this capability. So everything around verifiable AI is a domain which is quite interesting and will be solved. Now, the way to solve it and the way to get better performance in that space requires a couple of things. We mentioned FHE. We talked about, this entire podcast, we talked about FHE, but FHE is not one flavor. Within the FHE space, you have actually multiple flavors and multiple schemes. You have schemes like TFHE and you have schemes like CKKS and BGV. And each scheme, you can say, is probably more suited for different use cases. And schemes like CKKS and BGVs are better fit when you use significant amount of parallelization, and you don't necessarily need accurate response. So looking into these schemes and making them faster from a scheme perspective is one path. The second path is the intersection of FHE and hardware. Today, I would say probably most of the FHE solutions that are out there are running it on a CPU. Some of them are starting to look into utilizing and running GPUs. But for me, where the future is going to be is once we start seeing FPGAs and even more ASICs that are going to come into the market. And there are actually quite a lot of companies that are looking to build hardware acceleration for FHE. Because we have to acknowledge that unlike technologies like ZK, which are predominantly in the Web3 space, FHE's potential is in Web3. It will start in Web3. It will be in the crypto space for sure, but it will actually go beyond the Web3 space. We've seen the Apple announcement about them utilizing FHE as part of their product. So that is why you actually see a significant amount of hardware companies investing in FHE hardware. For me, this is like the more, if you want to dream and look at the vision, which is not that far. Like we say dream, but for me, this is not like a 5 year into the horizon, but rather significantly shorter. This is where we're going to see a significant growth around FHE and AI.
Great. You just front ran my last question and gave us a perfect answer. Okay, I think we can ask our final question, Omar.
Yes, with Guy Itzhaky, with your vision, we'll leap to the final question, which we ask all of our guests. That is to name a project you are bullish about.
There is a project, but it's in stealth, so I'm not sure I can share a lot about it, but it is a project that is utilizing FHE and FHE acceleration to provide developers with a very easy way to run FHE computation and machine learning models, which is exactly what I just mentioned a few minutes ago. But it is in stealth, so I'm not sure I can talk a lot about it. Gaizi, maybe you have others.
You know, I'm gonna say something that's maybe unexpected, or maybe it is, but I'm very bullish on Arbitrum just because we worked with that team for so long. I know it's a big project already, but I feel that it's underrated. They are one of the best technical teams I've seen in the space. They understand the market, but they also build with a vision for the future. And I just feel fortunate to be building with people like that in the space, like especially when we're becoming a bit more cynical with like meme coins and other trends taking over, which is fine to an extent, but it's always good to see those kind of like people that you want to more align with and feel that they're going to actually help you bring the future that you want into the space.
100%.
Yeah, fantastic. Okay, so with that, we'd like to say thank you, Guy Ziskind, Guy Itzhaky, for joining us today. I had a great time learning about Fhenix. We should definitely meet again and catch up in a few months because there seems to be a lot of work and progress being made in this space. So again, thank you. Also, thank you, Queenie. And for those interested to learn more, we've added some links in the show notes. That's all.
Thank you.
Thank you for having us.